Hello everyone. So until now we have learned the simple type of variable sized sliding window, but today we will cover the uh, higher level topic of it containing bit manipulation plus sliding window. The same way we have covered bit manipulation plus prefix suffix prefix sum using map. Okay, if you remember. So there I've already covered the prerequisites for bit manipulations. Okay, so please do watch that first before watching this video. I'll provide you the link in the description here also. The prerequisites of the bit manipulation before moving on to this topic. Okay, so bit manipulation plus sliding window, it is nothing but a type of variable size sliding window only. Okay, a type of variable size sliding window. So the same template applies over here also, which we have learned in the variable size sliding window. The same templates. Okay, but here we have to play with bit masks. Now, what is the change with our normal sliding window and the change in the bit manipulation plus sliding window? So up until now what we are doing, we in our template, let's say I will take the template of maximum size sliding window. Okay, maximum window size. So what we will do, we'll do some calculations. So let's say there is sum, so we will do sum plus equal to nums of j, and then what we will do, if sum satisfies or if condition satisfies, not sum, if condition satisfies, we will update our answer accordingly, and we will also do j plus plus. These two things which we are doing. Else, while condition does not satisfies, okay, so while condition not condition satisfying, and then we have learned that I less than equal to j, what we will do, reverse calculation. Reverse calculation, that is, here we have done sum plus plus, so here we will do sum minus equal to, and for I part, and we will slide the window from I by doing it by I plus plus. And here also we will check if condition satisfies against. Okay, then we will again calculate the answer and we will do the j plus plus. So this is just the overall template of our normal variable size sliding window which we have learned until now. Okay, I will recommend you, if you have not watched simple variable size sliding window also, please do go and watch it. So now what is the difference with the bit manipulations plus sliding window? So for the bit manipulation, let's say there are three main conditions in the bit manipulation: and, or, and, or, and XOR. Okay, but none of this we cannot do, like, okay, we have done sum and equal to nums of j while doing it, and in the else part, in the while part, while doing the sliding window, we cannot do again sum and equal to nums I. No, this we cannot do. Or in simple words, if I can say, there are no reverse operations for this three and, or, and XOR. So what is the solution for this? So every time what you have to do, you have to make one vector of set bit of size 32. This will indicate this will indicate how many bits are set at ith index. That means, let's say I am calculating it from I to j index. Okay, for I to j index, there are, let's say there are three such elements who have bit 1 at index 0. So my set bit of 0 will be 3. Why? Because three such elements are there who has contributed a set bit, a bit of 1 at index 0. So my set bit of 0 will be 3. This is for calculation part. Now when I'm sliding window, when we are sliding window for ith part, okay, then what we will do, if that part has set bit at some particular kth index, then we will remove it. So we will do set bit of k minus minus if that part has set bit, if that element has contributed to the set bit. Okay, so if I move quickly to the template of it, let's say for the maximum only, if I'm doing the template, okay, for minimum also the same thing, the same thing which we have learned in the variable size. Okay, just we have to do some replacements. So I have, let's say, the set bit of k. Okay, we have the same thing, I0 j0, and our template goes on as while j less than n. Now, while doing the calculation, first we have to calculate the set bits. So currently we are at nums j. So what we will do, for int k is equal to 31 to k greater than equal to 0, k minus minus, if nums j and 1 left shift k, that means nums j has one bit 1 set bit at kth index. If that is the case, then we will do set bit of k plus plus. Okay, so this is the calculation part. Now for the maximum size, what we will say, if condition satisfies. So for condition satisfying, we will have one function make over here. We will made one function outside of our main function. If condition satisfying, this is have a different function. This we make a different function, a safe function or function satisfying, something like that name. Then we will calculate the answer, whatever is asked. Okay. And then in else part, what we can do, while the function does not satisfies or condition does not satisfies, while not satisfies function and I less than equal to j, every time we will do the same thing again. Okay, same thing again for ith number. So we will do int k is equal to 31, k greater than equal to 0, k minus minus, if nums I and 1 left shift k. That means ith nums I element has contributed there, it's 1 at kth index, then we will remove it. So we will remove it because now we are not considering I number as we are sliding the window. So we will do it minus minus. Okay. And we will do I plus plus every time. Again, we will check if condition satisfies. The same thing now. Now the same thing which we are doing for the uh, normal variable size sliding window. We'll do it and we'll do j plus plus. Okay. And we will return the answer. So I hope you are clear. Because this three operations, AND, OR, and XOR, does not have any reverse operations, we have to play with each bit of that index of 32 size bit, okay, array. We need to play with these things. That okay, this element has contributed. Now, if I'm not taking it, so this element's one is removed. So now is it satisfying the condition with AND or whatever is given in the question? Okay, this is how it will work. So let's just quickly move to the question and you will get through it. So this is a simple level lead code question where here you are given an array nums consisting of positive integers. We call a subarray of nums nice if the bitwise end of every pair of elements that are in different positions in this subarray is equal to 0. So when we call that subarray nice, when two different indices, any two different indices of that subarray should be equal to, the end of that should be equal to 0 for every such pair. We have to return the length of such longest nice subarray. A subarray is a contiguous part of an array. Note that subarrays of length 1 are always considered nice. Okay, so let's say if I take this subarray. Okay, let's say if I take this subarray 1, 3, and 8. So what could be the 1? Okay, so 1 is nothing but 0, 0, 1, and 3 is what? 0, 1, 1. 8 is 1, 0, 0, 0. 48 is 32 plus 16. So 32, 16, 8, 4, 2, 1 should be 0. And 10 will be 8, 4 will not be there, 2 and 1 will not be there. Okay, and rest all are zeros. So let's say this is the bit representation of it. Now what we have to do as per the template which we have made above. So every time we will go, we will do the calculation. So here we have to find out that any two such pair, for every such pair, the end should always be 0. So that means whenever we will make the set bit operations which I have made you learnt above, okay, the set bit of k, it should be 1 only, or it should be less than 1. It should not be greater than 1. This should not be greater than 1, because if at any kth index, if at any kth index your set bit count has becomes 2, that means that some particular number I and j, this end could be 1 at kth index. So it should be 1 left shift k at least 1 left shift k. Okay, let's say I will take this example of 1 and 3. Okay, so you have this 1 and 3. So for 1, the set bit, what we will do for initially for the calculation part, our set bit of size 32. Okay, so initially 0th index will be 1. So every numbers are 0 and this is 1. Now when 3 will come, 3 has 1 at bit 3 has 1 at bit 0 and at bit 1. So at bit 0, this will change to 2, and at bit 1 it will be 1, and rest all will be 0. At index 0 it will become 2, and at index 1 it will remain 1. So now this has become greater than 1. That means if I do end of 1 and 3, okay, I will get 1. The end of 1 and 3 is 1. It is not equal to 0. That means my function should be like that set bit at every for k 31 to 0. For k 31 to 0, our set bit of k should be less than equal to 1 only. If at all it is greater than 1 at any position, this means that the pair whichever has contributed their two ones, at least two ones, that end will not become 0 at that position. I hope you got my point. Okay, so let's just quickly move to the code. The template will remain same as we have learned in the previous only. Okay, let's just move to the coding part. Fine. Okay, so we will have one int I0 j0, and we have to find the longest nice subarray, so maximum length subarray only. So let's say this could be at least 1. They have said that subarrays of length 1 are always considered nice, so at least answer should be equal to 1. Now while j less than n, what we have to make, we have to make one set bit array of size 32. Now every time we are at the jth element, we'll go k is equal to 31 to k greater than equal to 0 if nums j and 1 left shift k, means at kth position j element will contribute its 1, and nothing we will do, nothing but we will do set bit of k to be plus plus. For all this stuffs like end 1 left shift k, you just need to go to the bit manipulation prerequisites. Okay, so now our calculation part is done. So we'll check if condition satisfies. So we'll make one function called safe. Okay, safe, and what we will pass, we will pass the set bit array over there. We just need set bit, we just need to check that in all 32 if it is greater than 1 or not. So if that is safe, then what we can do is we can calculate the answer to be maximum size. So size of the window is j minus I plus 1, and we will do j plus plus. Otherwise what we will do, if it is not satisfying, then while this condition is not satisfying, so our condition is represented as a function over here, we will create this function, and until I less than equal to j, what we will do, again we will move to a loop of this thing, and now we will remove the things of the ith nums. So if nums I and 1 left shift k, so if nums I has anyways contributed here, then we will just remove it. So set bit of k will be minus minus at this point. Okay, and every time we have to do I plus plus. Fine. After coming out also we will check first if safe, then we will just update our answer, and of course here also we need to do the j plus plus. Okay, we'll return our answer over here. See how simple it has become. Okay, so now we are going to try another question which is a bit harder than this. This is nums dot size. Oh, we are left with the safe function. Fine, so we will have bool safe, and what we will pass, we will pass a set bit function over here, set bit array over here, and we will check for int k is equal to 31 to k greater than equal to 0 if any of this bit is greater than 1, that means it's not possible. So we'll return false. Otherwise, it's possible. So we will return true. Simple. Clear. Let's just quickly move to another question. Okay. So you're given zero indexed array nouns of length n consisting of non-negative integers. Now for each index I from 0 to n minus 1, we have to determine the size of the minimum sized non-empty subarray of nums starting from I inclusive that has the maximum possible bitwise or. So we need to return answer of size n where answer answer of I is the length of minimum sized subarray starting at I with maximum bitwise or. So let's say we will take for index 0. What does the question means? That if I'm taking from 0, then from 0 to n minus 1, okay, how many numbers I have to take starting from 0, so that if I take that much number from 0 to particular jth index, okay, I'll get the maximum possible or which could be possible with 0 to n minus 1. So maximum possible or would be what? That is the first step to determine. Okay, the first step to determine is maximum possible or will be what? So maximum possible or is take all elements, take all elements from I to n minus 1. They have said that we have to take starting from I. So starting from I until last index, every element if we will take, we will get the maximum possible or. Okay, so for index 0, if I take every element, so 1 0 2 1 3, these are this bit representations, the maximum possible or could be what? 3 1 1, which is 3. Okay, so now from 0 index, starting from 0 index, how many elements I have to take such that I can get this 3? Of course, I'll take, if I'll take all the elements, that could be possible, but that is the maximum answer. We have to find minimum such a size so that we can get this maximum possible or. So let's say if I take 1 0 1, okay, then 0 1 or 0, this is again what? 0 1 only, or 2 2 is 1 0, this I'll get 1 1. So if I take 1 0 and 2, this 3 only also, then also I'll get this 3, which is maximum possible or only. Now if at all I'll take this 1 as the or, this answer will remain 1 1 only. Again if I or with the last 3, which is 1 1, the answer will remain the same 1 1 only. So if I take this first 3 elements also, I'll get the maximum possible this thing. So my size of this is 3. Okay. Again for index 1. So at index 1, what could be the maximum? Uh, this will be 0 or 2 or 1 or 3. So every time for index I, this we have written. Okay. First step, maximum possible or will be to take all elements from I to n minus 1. So this is our predicted answer or the answer that should come, the maximum possible or that should come. Now from that particular ith index, how many elements I need to take in the subarray so that I can get this maximum answer without going until the end. That minimum sized subarray we need to find. I hope we are clear. Okay, so what we will do for the first step? What we can do for the first step? So for the first step, we need to find maximum possible ors for I to n minus 1th index. So we will calculate one suffix or, okay, of size n only, where suffix or why suffix or, because we do not need to find from 0 to I. Here the case is from I to n minus 1. So for n minus 1, it's just the nums of n minus 1. And now every time we will go one step ahead, we will do suffix or of I is equal to up until now whatever we have got or with the num psi, because now we have to take num psi and we will move this loop backward from n minus 2 to I greater than equal to 0. Okay, this is the first step. Now our second step, the same thing. We will calculate the set bits also over here. We will calculate the set bits over here and we will check. Okay, let's say my set bit is filled. I am at jth index. So we will do while j less than n. We have calculated those set bit of size 32 is done. Now what could be my safe function over here? Just we have done in the previous question. Like how we will check. So they have told that that until particular minimum size non-empty subarray, that or should be like maximum possible or only. Okay, that means if at all my suffix or at particular index from 32 bit only we have to do. So from 32 bit, if my suffix or has set bit at particular index, kth index, then my set bit array also should have at least at least one over there. So let's just move to safe function. What do I mean to say? We will have two things over here. One is the set bit and one is the suffix or at ith index. Okay, that okay, from I to n, this is the thing. So that suffix or of I we will pass over here, which is the maximum possible or. Now what we can do is we can run a loop of k greater than equal to 31, k less greater than equal to k is equal to 31 to 0. We will check if suffix or, okay, this is suffix or of I, which I am representing as or only, or max or. This is suffix or of I, which I am representing as max or. Okay, so if the max or and 1 left shift k, this means if max or has set bit at kth index, okay, and if our set bit which we have passed, their kth bit is equal to 0, means there it is not the set bit from any of the element. This is the false case. Like okay, I need for or part to be the maximum, for or part for the same or I need at least one. For end we need only one. For a or we need at least one. Okay, for or we need at least 1 0. So here we need set bit of k should be equal to, if set bit of k is 0, means this could not be the case. So we will return false over here. And in else part also, else, that means else means max or do not have set bit over here, do not have set bit at kth index. And if we have got in the set bit function in this set bit which we have calculated, then that is also false. And if our set bit of k is greater than 0 at this position, okay, 1 2 3, anything could be there, then this is also the false case, then also we will have to return the false. Otherwise it's the true case. So otherwise we will return the true. I hope you got the safe function. This is the only thing we need to take care of. Other than that, we need to find the minimum size. So our template would be followed by what? If not safe, we will do j++ without doing anything. And else, in else part, what we will do? While safe and I less than equal to j, we will calculate the answer and we will slide the window. This is our basic template of minimum size. That is for the maximum size for the previous question. Okay, so let's just quickly move to the question part. Fine, we will have I0, J0. Okay, we need to return this answer. Here a whole answer vector of size n, and our n is nothing but this. So let's say our maximum length every time we are getting is 1e9. We have set it to the maximum because we need to set it to the as minimum as possible. We will have one set bit of size 32. Now while j less than n, what we will do first? For int k is equal to 31, k greater than equal to 0, k minus minus. If nums j and 1 left shift k, then we will do set bit of k plus plus. Done. This is the calculation part. Now this is the minimum size. So if not safe, I've already told you what is the safe function. We need to pass this set bit, and we need to pass this suffix or of I function. Now we have not calculated suffix or. So let's just calculate first suffix or function, suffix or vector. So we will calculate the suffix or of size n, and our suffix or of n minus 1 is nothing but nums of n minus 1. Now for int I is equal to n minus 2, I greater than equal to 0, I minus minus, we will calculate. So this suffix or represents what? Maximum possible or from I to n minus 1 of I is equal to whatever we have got till I plus 1 or with the current element nums I. So we are done. So we'll pass this suffix or, if not is safe, we'll pass this two things, our set bit and our suffix or of I. Okay, then we will simply do j plus plus. Else, while safe, what? Set bit and suffix or and I less than equal to j, we need to find the answer to be the minimum. So we will calculate this answer of I as the minimum of answer of I comma j minus I plus 1. Okay, now we need to remove. So for int k is equal to 31, k greater than equal to 0, k minus minus. If nums I and 1 left shift k, then we will remove. Okay, we will do I plus plus. Done. And here also in else part also we need to do the j plus plus, and we will return the answer. Now what could be our safe function? Bool safe would be, we have one set bit and one maximum or. We'll go for int k is equal to 31, k greater than equal to 0, k minus minus. If this maxi or and 1 left shift k, this means that kth bit as 1 over here, and if set bit of k is equal to 0, and this is the opposite condition, then we will return false. Else, this is not 1, maxi or do not have any set bit over here, and our set bit at kth index has some number of ones, and this is also false condition. Otherwise, we will return true. I hope you are clear. So for all such questions of bit, what we are doing under this n loop, until now we have seen that sliding window will take order of n time complexity. We will be running one loop of size 32 to make it set bit or unset bit. Okay, so the time complexity for all such type of questions will be order of n cross 32. Okay, let's just try to submit it. Fine, you're done with it. Okay, so as usual, I'll be giving you the notes for this, simple one page note of this, and these two questions which we have learned just now. I'll give you the links of that. You can try by your own. These two are actually very good questions of bit mask plus sliding window or bit manipulations plus sliding window, mostly asked in your interview rounds or the online assessment coding questions also. Okay, so our next topic will be at least or at most care related problems. As and when I go through the topic, you will get to know what are these type of questions. Those are also very famous questions, basically asked in the coding rounds and the first level of interview rounds. Okay, mostly. So stay tuned for the next video. Bye bye.